All right, I think we're ready. Today what we're going to do is we're going to look at Klipper. It is a firmware that sits on a Raspberry Pi in front of your printer. So I've done a few things. Let's check it. What I've done here. Let's get this out of the way. I took out our SKR, so that means I also took out our touchscreen. So now what's in the printer is actually not even the board that's original to this one. This is the 1.1.4 board. So it's an old Creality board, 8-bit. We lost our silent drivers. So these drivers here were the TMC silent ones. And you don't really recognize that they're so much more quiet. Actually, they are pretty close to silent. At least on the stepper motors driving. The other parts of the machine are not silent, but the stepper motors with this type of board are really quiet. And when you put the old board that does not have the silent drivers in it, then you can definitely notice that they were doing their job. So we have an old board in there. It's an 8-bit board. We have an old LCD screen in there, so it's just got the knob and there's no touch or anything. It's just the screen is the same as it was when we started with the Ender 3. The board actually is a downgrade from where we started because at least it did have a 32-bit board in there to begin with, but I put it back with one of the old boards just to show that this works with any board. There are differences in how we're going to set this up depending on what board you have. We'll look at some of how you can figure that out as part of the setup, but because it is different for each board each processor. So the little processor on there is going to have a little bit different setup depending on what you have in your printer. Most of the popular stuff is not necessarily a pre-configured thing for you, but at least they give you the information that you can use to pre-configure it. So these are no longer in there. And actually this board, remember, let me show you what went wrong with it. Remember, I had fan problems on it. I doubt you can actually see the problem, but we can point to the problem. So here, wow, let's make it not autofocus. Here, this is where the fan is going to plug in right here, the layer fan. Now remember, on your Creality boards, the layer fan plugs into a spot kind of in this area, and this area is the fan for the housing, the control box. They're backwards, or they're in different spots here on this board. This is, well, if I can actually read on the screen better, this is fan 1 at the top and fan 0 at the bottom. This one blew up. So here's a pencil. That tiny little guy right there has failed. So I could take it out and solder a new one in. Remember, these plastic headers, they just slide on there. So you can pull all of them out of the way so that you kind of get some room in there. But you'd have to desolder and resolder one of those. You know, they're super cheap. You probably can't even buy a single one. You probably have to buy a quantity of them for $1 or $2. But that one's blown up. And it's stuck in a position where the fan is either, I can get it to be completely off or completely on. I can't do anything in between. And once it's one of those, I have to reset the machine to get it to be the other one. So it can't just turn it on and off. It has to shut down and restart and everything, or unplug it. And so it's inconvenient. I had worked around that by taking the box fan, the controller fan, and wiring it over here to just always on. So that's fine, particularly since I was in an enclosure. It doesn't really matter, and it never really matters if you keep your electronics cooler until you get to like sub-zero temperatures. Like, I don't remember, negative 50 Celsius or something is when electronics start having problems, and we were not going to get to that, certainly not by applying a fan. So I wired it over here and then used this port for my layer cooling fan, which wasn't blown up. And it still worked. I just had to go in and set the pins. There's a couple of videos back about how I went in and changed in the firmware, the pin that was the layer fan. So we had worked around that. I think, though, that this driver has failed also because I think that was probably something I did though, but I don't know. Anyway, we took this board out. We went back with the 1.1.4 board, 8-bit board, which also meant we took out the touchscreen because we need to be able to plug in the touchscreen, and that board doesn't have a way to do that. So we're back to the 8-bit days on our printer. Just mention this since it did come in. This is the Nozzle X. It's a E3D nozzle. Actually, I think it's an E3D nozzle. It's the E3D size nozzle. And it's a hardened nozzle, but it's also coated. You can kind of tell it's got a little bit of a blue tint to it. It really does. That's not just part of the camera. It's got sort of a bluish tint to it for the coating that's on and inside it. So we're going to put that in. I actually don't know if I'm going to put it in the Prusa with the multi-material or in this ender here. We'll try it out. It's an expensive nozzle, so I've only got one of them. In fact, when they shipped it, I got it from Matter Hackers. When they shipped it, they put it in with a roll of filament, and it was just in one of those bubble wrap bag type things. And the original one worked its way out of the bag. Like there's a hole in the bag and a hole in the little bag that it was in, and a hole in the filament bag that was normally sealed up, and the no nozzle. So in shipping it was lost. I emailed Matter Hackers, and like the next day that day they had shipped out a new one. It came in a few days after that. So the idea with this nozzle is that it is coated, it's precision, it's hardened, and so we can do high temp stuff, and it should help with retractions, not having as much grabbiness inside the nozzle. We'll see. But I don't want to lose that, and I don't want to get it confused with the others. I'm going to put it back in here, and we'll put it off to the side. I haven't really decided where I'm going to put it yet, in which machine yet. In the Prusa, it would be good because it has that multi-material upgrade on it, which is working fine. But the one thing that can happen is when it changes filament, it pulls the filament all the way out and puts new filament in. And if when it's pulling that filament out, the one that it's taking out, if it's pulling that out and it doesn't form a nice cone shape on the end of it, when you pull filament out, it can sometimes have a blob on the end of it. If it doesn't form a nice cone shape, then it won't be able to pull it all the way out of the machine, and it'll get all jammed up. And so this particular nozzle is supposed to help being coated to always form that nice retraction shape without the blob on the end of the filament. And it's a high temperature nozzle, so it could be good for any printer also. So we'll see which one I'll end up putting it in. I may put it in one and put it in the other one after that. So we've got our Ender 3. It has the 1.1.4 board in it, and it's working. I've actually already put Klipper on there because we won't be able to do all of the install we can do all the install. It's already ready, but there's a section of it that takes about 15 minutes that I don't want to do just sitting here watch for it to do stuff for 15 minutes. So I've already done that part. So we'll simulate that part. So what Klipper does is it takes any board, a modern one or one of these older boards, and uses the board itself as really just controlling the stepper motors. So, and the fans and things like that. But it takes the processing out of the board. So the processor, we can go back to our little board here. Where are we at? There we are. The processor over here, right there, normally has to interpret the G code, figure out how to make steppers move to produce that kind of code. And so there's a lot of processing involved. And particularly the older boards are bad at that. Well, they're not bad, but they're slow at that. Newer boards are faster than that, than the older 8-bit boards. They can process things faster, but there might be some things you want to do that require a heavy processing load, and these boards just can't do that. So you can take Klipper, take all that processing away from the board here and put it out front in a Raspberry Pi, which is a computer with significantly more processing power than even a modern board, and let the processing happen on the Raspberry Pi running Klipper, and then all of your board in your printer does is execute the command. So it turns the step, it still has the stepper drivers in here, and it still has the fans and the limit switches and everything. So it's just doing very simple tasks for it to do. And it can do those much faster than it can go in and process the G code and also do those commands, execute them. And so we take a lot of load off of this, put it on the Raspberry Pi, which can handle that, and now we suddenly have the ability to drive steppers much faster, because all your board has to do is drive the stepper. It doesn't have to process and drive. And so we can do a lot of things that we couldn't do before. We can either do things faster, or we can do things faster and just stuff that we couldn't do before. So what we're going to do is I went to Fluid, let's see, fluid.xyz is the actual address here. Is it? Yeah, it's on your screen up there. So in here, Fluid Pi is going to be sort of like our Octoprint front end that we can look at on a web browser. So I'm on a PC, but I suppose, I didn't try, but I suppose you could look at it on a tablet or whatever, because it's just a web browser based experience front end. So I went here. There are two of these. I think Fluid Pi and Mainsail are I think Mainsail is the other one, that are basically the same thing, and they're specifically built to interface with Klipper. You can use Octoprint as your interface, and it will work also. I thought and I've done that in the past. The deal with using Octoprint is that you couldn't use one of the lower level Raspberry Pis. Now I've got this on the same Raspberry Pi that we had before, so it's the 3B Plus, but technically you could run on one of the zeros, but Octoprint won't run on one of the zeros, so or it will not run well on one of the Pi zeros. So they're cheaper, and you can do this with that, but if you're running one of the Pi zeros, you pretty much have to use one of the front ends that's made for Klipper, not the Octoprint front end or interface. All right, so I did that, downloaded this. It's like a gigabyte file. This is the one that I was having trouble downloading in the last lecture. I mentioned it just wouldn't download. Once I got my internet, it was my internet that was slow. Once I got my internet stopped doing all the other stuff it was trying to do, stream and everything at once, then it worked fine, and I downloaded it. So it is a gigabyte or so, 1.2 gigabytes maybe. Let's see. Oh, 1.07 gigabytes. So I downloaded this guy. I didn't get the source code. I wasn't going to try and edit it. I just wanted the installation. So I got that thing. So there's an image inside there. I used our Raspberry Pi imager. Choose the operating system. So it starts out, there's several built-in and the things you can go get. I used a custom one, and once you extract or unzip the file that you just downloaded from the Fluid site, you have this image file in there. So you pick this as your image, open it, choose your storage. So you're going to put it on one of those the micro SD cards. And so you definitely want to make sure that you choose that card and don't write this image to your PC or something accidentally. This Raspberry Pi imager is pretty good about only showing you the option of an SD card. I don't know what it would show me right now. Yeah, I don't have anything, and there's no SD cards plugged into the computer right now, so it is saying, well, I don't see what you want to write this to. So assuming you have an SD card, even if it's not blank, but an SD card, it'll probably pop that one up in this option here. It will erase everything on the card, so make sure it's not something that you wanted to keep and add this on top of. It's going to be a totally blank card with just the Fluid information image on there once you're done with this. Once you've clicked that, you click on write, and this is the part that takes about 15 minutes or so to totally complete. And so at that point, you have an SD card that is that has this image of Fluid on there. Looking at the instructions here, so that's this section. Now it says here Linux or Mac users Raspberry Pi Imager. Raspberry Pi Imager does now run on PC also, so you can get a PC version of this. if you don't want to use it for some reason, actually it's a really good imager, particularly if you often write different images to Raspberry Pis. It's a good one. Balena Etcher is more generic, and it would do a similar thing where you download the image, you select the storage and hit write. So it's the same type of thing, but I kind of like this one. So I've started using it. The next thing you want to do is set up your Wi-Fi on the card, the SD card that you just wrote stuff to. There's going to be a file, this file right here, fluidpi wpa supplicant.txt. That will be in the root directory of the SD card. So if you read the SD card like you would any other SD card on your PC, so you might have to take it out, plug it back in so that it recognizes it. It might tell you something along the lines of it needs repair or whatever. Don't do any of those things. Don't format, don't repair, don't do any of that stuff. Just open it up like a SD card with normal files on it. Find this file and edit it. Let's see if I want to do this. I don't even know if I have a good way to show you how to do this part, but let's see. I can probably come up with something. I'm going to get the SD card that that has our image on it so that we can look at it. Let's turn off all of our stuff because I might have to edit it first. I might have to like hide my Wi-Fi info. Oh, well, so I will show you this. Well, I can't show you, it's off the screen. But when I put the card in here, it says there's a problem with this drive. Scan and fix it now. I don't want to do that. I just want to open the file, or the what? Not that one. That one. I just want to open the image. So it came in as boot G:. There's the file we want to edit. You do want to edit this. It is a text file, but you don't want to edit it in something like Microsoft Word or an actual word processor. You want to edit it in something like Notepad. I'll use Notepad++. So right click, select it, right click, and edit with Notepad++. This is a part where I'll have to change something real quick. No, we'll do this too. All right. So it opens the file. This is Notepad++. The reason you don't want to use something like Microsoft Word or Google Docs or whatever is that there's a probability that when you save the file in one of those word processors, it's going to add some metadata to the file that is not going to be readable by your Raspberry Pi. It's going to corrupt the file in a way. It's not going to be corrupted. You can still open it and do everything you normally could with it, but that metadata interferes with what the Raspberry Pi needs. All right, so it'll actually start like this. So it'll look like this. So you find your type of internet. So are you just on an open, unsecured Wi-Fi? WPA2 or WPA, that's probably the one that you have set up if you're at home. There is a WEP, that's a much older but secure, so it requires a password protocol. You might be on that one, but I'm going to assume that WPA2 is the one that you probably have set up. If you don't know, then if you log into your router, you can see what kind of security it has. Remember, you can log into your router usually by going to a web address 192.168.1.1. That's usually your router, your local router. And in there, it'll show you your security settings and what you have installed. If you're not at home and you're at a place where there is a username and password to log in, suddenly gets much more complicated. That enterprise type of Wi-Fi login is not the same as these. You can sometimes get it to work. It's just more difficult because you also have a username and a password. This is assuming that it finds this network name. So this SSID is your network name. So the thing that shows up on your computer as the name of the network, whatever that is, you type it in verbatim, and then whatever password you need to log into that network. So password 123 goes here. That's not enough. You also need to these hash marks or octothorpes. These are commenting out all of these lines. So in order to do this, you have to subtract or erase these. These two, where there's two here, you could erase one of them, I suppose, but that is not part of what you need to activate. This is just a label telling you this is the setup for the WPA or WPA2. So you put your information in here, save the file, which I'm not going to do because this is not the information I want. So we will get off of that one and do not save. And we can leave those up. All right. We'll come back to that. All right. So then you've got a, well, let's eject our thing because we actually need this to, oh, it's probably, there we go. Well, sometimes they won't eject. Let's try one more time. There it goes. You had too many things open that were related to that file. It is always better with these to eject them versus just remove them because they do tend to get corrupted pretty easily if you don't. Okay, let's start that guy back up so that we can look at it. So what I've done over here is I put the SD card in. It's got my Wi-Fi information in it. And I put it back in the Raspberry Pi, plug the Raspberry Pi in. So we are at this level right here. So boot Pi from the card. All right, then it says log into your Pi via SSH. So that's a secure socket type thing. What's it? Secure shell. That's what it actually is. If you have Bonjour on your computer. So if you have a PC, you probably don't have this. But if you have like iTunes or something like that installed, you probably do have this. I don't have any of that. So I have a PC without iTunes. And so Bonjour is not on my computer in any way. I could install iTunes and it would install it also. And there's probably some other ways that you can install it separately. So what I have to do when it says to log into your Pi via SSH is instead of typing in a web browser this, I have to go actually find the IP address of the Raspberry Pi, which I just rebooted it, so it might have changed. We'll have to see. So what I would do is to log into your Pi via SSH, normally what I use is a program called Putty. Let's see, here's Putty. So, well, can't see that. There's Putty. And you can type in your host name or IP address. So that's that 192.168. It's probably going to be .1 and then dot some number. It's usually a low number. Last time I was here, it was 8. And so this is on your local area network, the IP address that was assigned when you booted up the Pi. And connected to your network router. Let's see if mine's still that. I don't know. All right, it is. All right, so then it says log in as. Now here, I believe they tell you, yeah. So the first time you do this, and until you change the password, for any Raspberry Pi, actually, the password, the username is Pi. So log in as Pi. And then the password is Raspberry. Oh man, I think it's probably going to, maybe I typed, yeah, okay. So now we are in a secure shell talking with the Raspberry Pi. And so here, what we want to do is, there are some options. This part is actually optional, but you run these commands here, if you want to change the time zone, set a different password instead of Raspberry. You know, change the host name. So maybe you don't want it to be called FluidPi at .local, but you wanted to call it something else, FluidPi1. Maybe you have 10 of these things and you want to differentiate them all. So you can change all those, or you can leave all this the same and not do this step if you don't want to. So what this lets you do, though, is it lets you change the password so that if you're in a place where other people might be able to guess that your password for your Raspberry Pi is Raspberry, like they all start out being, then you change it, and you can have a little bit more security. Out here, there's nobody like that can, you know, get close enough to my Wi-Fi to actually do that unless they drove up to the house or whatever. So so you can change all these things, but they're kind of optional. You probably do want to at least set the right time zone so the Raspberry Pi has the right time associated with it. But the others you can leave alone, and you probably do want to change your password to something that is not just the default. All right, so what that lets you do is now you can go to that address in your, let's get on the screen here, in your web browser. So you can log into that address, and well, you will probably get some errors. So it'll eventually look like this, but you'll probably get a set of errors at the top of your screen up here saying that there's no printer configuration file, you know, all this kind of stuff. And that's because you haven't built a printer configuration file. So this gets you to where you've got Fluid. This is Fluid. This is the interface screen where I can do the normal type of things that you would think you could do with talking to a printer. So it kind of takes your control panel and puts it on here. So it's like what Octoprint was doing. So there's your homing over here. You can go to a specific location. You can do extruding and retracting. Here's a baby stepping type of thing if you want to move in very small increments. If you've built some macros, they would show up here. Control the layer cooling fan. You control some limits, or at least you can drop them down. If you want to change these maximum limits, this in the configuration file. Here's a console where you can send it G-code. If you want to send particular commands to the Raspberry Pi. Now, the Klipper does use most G-code commands, but it also uses extended G-code, which means that it has some additional commands, and they're usually not actual G-code, so they don't look like G28. They look like bed mesh leveling, and you know, it's a whole word or a phrase. And so it does have some extended G-code commands. It gives you a little readout on your bed and heater temperature, extruder temperature, so a plot and that. You can turn the plot off if you want to, turn it back on. There's some presets. Well, I've only got one in there right now. For like maybe you want to preheat for ABS or preheat for PLA or preheat for nylon or whatever. And then there's the all off version. And so this is kind of what your front end for interfacing with the printer. You also have a list of jobs where maybe I've got these two loaded in that I've done in the past. So, but maybe you've sliced something. So you add a new sliced file. So these are both G-code files ready to be printed. Here you've got just a history of things that you've done. Here's two that I quit for one reason or another. One after 13 seconds, one after 3 minutes. I think this 13-second one, I didn't have the Z offset right, and it was just printing in midair. This one, I don't remember why I stopped it, but I did. It gives you some, you know, total print time that we've run. So far, 3.5 hours on this installation. Total filament, you know, average, all kind of stuff. I don't have anything in the tune section right now other than end stops. This configuration, we'll come back to that one. Here's just kind of some data, you know, if you're interested in data type things. And then there's some settings over here that you can create new macros. You can control cameras. I don't have any connected to this one. You've got G-code previews and things like that. In this configuration, you have several files, and you probably don't have any of these printer.cfg. You don't have a printer configuration. You probably have these three: fluid, moonraker, and webcam.txt. Those are probably the three that you start with, and you won't get very far. You won't be able to interface with your printer other than talking to the Raspberry Pi and seeing this screen, but you won't be able to do anything on it until you build a printer configuration file. So over here this is the Klipper, what is it, klipper3d.org. They have an installation process that looks similar to what we just did, except now what we need to do is on that Raspberry Pi, we need to get it ready to interface with your actual printer. So you don't need to do this part here. This is if you follow the fluid route. So we did fluid. We're not doing Octoprint, so we don't need this line. So we could start here. So we're back in PuTTY. I can probably do this without destroying what I've already done. So let's see if we can find PuTTY. I might have closed it. I think I did. All right, so there's PuTTY again. Let's go back into it. So you just type your IP address. Remember, if you don't know the IP address, if it just assigns one at random, which it does, and you don't know what that is, then you need to go to 192.168.1.1 in a web browser. So just type it into the web address bar. That should log you into your router. And then in your router, not only can you see the type of security you're using, but you can also see connected devices. And you click on connected devices, it'll bring up a list of all the things, and you'll actually probably be surprised at all the things that are connected to your router. And so you can look through there. One of them will say fluid.py, I think is what it says. You'll see it's something Octoprint, not Octoprint, but fluid. It's Raspberry Pi, and it'll have fluid in the name of it. And that'll tell you the web address or the IP address, not web address. This is a local IP address for your Raspberry Pi that you just set all this up on. So we'll PuTTY, we'll log in. So I guess we could have stayed there. We didn't. Well, no, we had to boot it back up, didn't we? I guess I did have it logged in. I have two of them there. All right. So then you start following these commands. So you type, actually you can cut and paste if you wanted to, but, can you cut and paste? Yeah. So it's different if you do want to cut and paste, and there's a reason you might want to in a minute. So in this terminal, to copy something, you just highlight it, holding down the left mouse button, and then let go. That is copy. And then paste is wherever you want, you click wherever you want to paste it and right click, and that will paste. Now I don't know if I can copy this stuff or not, but paste is just the right mouse button. Copy is just the left mouse button after you've highlighted something. All right, so cd tilde Klipper. So now we're in that's changed directory into Klipper. So now we're in the Klipper directory. And now we want to do this make menu config. So I just copied it, Control C, and then right click over here to paste it in here. This is where there will be some specific things to your processor that you need to find out. So if I do this, this is what you get. All right, so to figure out what you need to put into all of these spots, they're in here. Let's see if I can find where they're at. All right, so scroll down. I don't know why they don't put it up here, but they don't. Because they're not quite ready for it yet. It says select the appropriate microcontroller and review any other options provided, and they give you this. And so you may not know what at all to do. go down a little bit to this config directory, or the config reference, whichever. These are examples for many different printers. So here's our Mini E3 version 2. That's the one that we did have in there. We have, well, here's some newer Crealities. These are the 32-bit Creality boards. And there's, all the Rambo boards, Ramps boards, Smoothie board, ANET boards. Here's the Creality Ender 3, the older board, the one that I actually have in there now. And so there's probably, unless you have a really oddball printer, probably in this list somewhere is a board that is going to match up with the one that you have. So you find it in this list. If you really don't have one, find one close to what you have in here. And I would assume that if you had an oddball printer that wasn't on this list, you would have it for a reason and you would know this kind of information already. But let's just look at the one that's, where'd it go, for the Creality board that I do have. So I have this Ender 3. All right, and so they start out. This is the printer configuration file. So you could just download this and use it as your printer configuration. So you do that part, but at the top of it, in this little section, it gives you the information that you are going to need to set up this menu config thing. So all that this one says is, to use this config, the firmware should be compiled for an AVR ATmega 1284p. That's it. And then there's another little note down here that sometimes you have trouble and follow this stuff. But this is it for the configure for this deal. So you go into the this is a mouse, so you can't click on these things. You have to use arrow keys. So you go into the microcontroller architecture, you pick out the one that it says ATmega 1284p. All of these you leave alone, and these, it doesn't say to change any of these things, so you don't. And then you hit Q to quit and save this. Now I don't actually want to do that. I just want to exit and leave this alone. So you would save it, and then you would be ready to do the next step. Let's look at the Skr configuration because it is different. So where are they at? Big Tree Tech Skr Mini E3. All right. So same type of thing, except there's all sorts of things you need to do. So in this one, compiled for an STM32F103. So in here we would, in here we would have to pick STR, and that would change our options. STM, actually, that would change our options here. And then we would select the 28 kilobyte bootloader. We would select USB. It doesn't actually say USB communication, but there's only one option that says USB on it. So you select that one. There's another button that pops up for enable extra low configuration options. And then the Gpio pins, you click on this one and you type in the PA14 like it says right there without the quotes. I actually don't need that on mine though, so I'm gonna leave it alone. And then you're ready to do the make file. So I'm gonna quit. Oh, okay. Well, I didn't change, no changes to save, so it just quit, which is fine. I didn't want to change anything on mine. So at this point, you've got it ready to make the file to talk with your printer. Let's see. Let's go back to where we were. All right. So we're right here. We just did this. So depending on your board, and I should have pointed that out in there, the Skr boards won't let you do this. So there's a different process that it talks about. And in fact, let's go back to that because you might be using that. Here. So the make flash command does not work for the Mini E3, which is the one that we did have in there. So instead, after running make, which we haven't done yet, and I'm not going to do because I don't want to do that part for it's already done. You have to go into the SD card, into a folder called out, and get clipper.bin. So that's the firmware. Put it on an SD card. Put that SD card into your printer, not the Raspberry Pi, but into the printer. Boot up the printer, and that's how you'll upload the firmware. The Mini E3s just won't do this next command the way the others will. So what you would do is you'd be in here. You've done the menu config. You type in make, hit enter, and it's going to go through and make the firmware. At that point, you type in this, and you will get out a name. So there'll be some kind of name for your printer. Something like this. It won't at all be this set of characters, but it'll be similar to this. And so this is where you probably want to copy. So you would just highlight it and let go. That will copy it. And you're doing that over in this window. And then you do these commands, assuming you're not doing the SKR mini board that won't do these. You stop the Klipper service. So that's this line. So you type in this line, hit enter. You make flash in this part right here is what you just copied from here. The whole thing, the path directory or path and the actual name of the printer all into here. And then it will run and it'll make the, it'll actually send all of this to your printer. So you do have to have your printer connected by USB to the Raspberry Pi at this point. Otherwise, it can't send it to the printer. So at this point, your Raspberry Pi is connected through a USB cable. Remember, you set it to USB up here. Well, actually, it said that in the configuration file, didn't it? But it says right here also, connect via USB. You won't even be able to do this line if you don't have the USB connected. All right, so this will flash the firmware on your printer. At this point, your printer won't boot up on its own anymore. You'll be able to turn it on, but the screen will just be blue or just on. It won't do anything. There will be no text on it. So then you start the Klipper back up. And this line right here is reminding you to don't copy this line. This is not the name of your printer. Put in your printer's name here. And then go get the configuration file that you want and save it. So we would want this one, Creality Ender 3. Save this file. So either download it or cut and paste it into Notepad or whatever, but all of this, and save it as printer.cfg. All right. This file needs to get onto your Klipper installation. I suppose you could probably just go in and take the SD card out, put it in your computer, and put the file on that way. That gets a little bit cumbersome, and probably not. And you could do that also if you knew the correct commands to do it in here. You could do that, get the printer config file. I think maybe that's what they talk you through here. Yeah, right here. So you could copy that printer config file into your installation with these commands. If this is not, not making sense, and now you wouldn't want the example Cartesian config, you would want the one that's relevant to your printer. And then you would be ready to boot it up and actually print, or will at least go to the next step of setup with your printer using Klipper. So one thing in this configuration file, this name from here, the one that you got by running this command, this name has to be in the printer configuration file. So there's a section called MCU, so that's the controller. Let's go back over here. and look at it. Where are we at? There we are. So in here, there's a MCU right here. So it's got something in there already. It's not at all right for what you need. You need to leave serial colon, leave that part, and then put in that printer's name for your particular printer. Put it in here, cut and paste in here. That way it will actually talk with your microcontroller. All right. That should be enough to at least get your printer up and running. So when you go over here, you might have some warnings at that point that there are some missing macros or something like that, but it will connect to your printer. The missing macros, let's see, where can we get those? Well, this is all the things to verify to make sure that you actually can control the printer. I don't remember where the easiest place to get those macros are. Is it in here? It looks very complicated, and it can be. There can be little bits that if you want to tweak some things, it can be tricky to find the actual piece that you want. This is not the piece that I want. Although there's your bed mesh leveling, which if you have a BO touch on there, you might want that. All right, this is not, well, what'll happen actually, and mine's not doing it because it actually, oh, let's fix it then. Let's make it do it. Oh, well, let me show you what I'm doing here. So you've got printer config. After you've done that step of getting the printer config file onto the onto your SD card that is running on the Raspberry Pi, you can edit it in Fluid. You don't have to open it up, and you know there's a connection between your computer's web browser and the Raspberry Pi. And so you can edit directly on there. You don't have to download it and edit and re-upload it. I was going to show you another way to get that printer config on there, and that is using... I can't move this one. Oh, I have to drag the right window. WinSCP is maybe it's a little bit more obvious on how to move files around. So it works the same way as PuTTY, where you type in the address, the IP address of the Raspberry Pi, username and password. I am currently using the one that is built in there. And I don't want to edit it. I just want to go to it. No, I just want to go to it. Log in. All right. And there's the password. All right. So it may not bring you to this directory, but notice the directory home pi Klipper config. So that's the path that you want to find. That's where printer.cfg will originally go. So if you didn't want to use the commands with the nano and all that I showed you earlier to send printer config to this location, WinSCP is much more intuitive on how it works. So if you're not familiar with the shell commands that we were using in PuTTY, then this is probably more obvious what's going on. This side over here is your local PC, and this side over here is the thing that you've logged into. So it's the Raspberry Pi. And here I've found wherever I saved the printer config. So we had we went and found it over here, downloaded it, and saved it somewhere. And this is that somewhere. And there it is, printer.cfg. It may not be named that when you download it. It's going to be named one of these generic bigtree tech.skr or whatever. So you do have to rename it printer.cfg. And then you just drag it over here and into this directory, home, pi, Klipper config. There won't be all these others in here, like this one, and this one won't already be in there. It'll have Moonraker, Fluid, and Webcam. and then you add printer, and then you close this thing out, and that's it. You've put the printer config on there, and at that point, yes, at that point, you shouldn't have errors, but you will have those warnings. So here in the configuration, you can click on printer.cfg, just left click and edit, and there's that printer configuration file. Now this is not the one that we started with because I've edited stuff on it. But like, here's what would happen. Let's just take out the pause, remove, or resume. So that's not there anymore. I just commented it out. Save and restart. All right, so this is the kind of error you will get. Existing command pause is not found in the G-code macro name. So there will be 3 or 4 of these things that it's missing these macros. Now normally it actually tells you where to go to get these, but this one didn't. Let's try another one. So to fix that, you would just add in, you'd literally type in this pause resume. Let's see if I can find, maybe in here, no, that's not where. Maybe this one will send us to the right place. Because it usually gives you a, well, no. All right. There is a location where these things are stored that you can just cut and paste them. I don't think it's that. It's not in there. Oh, that's something different. Nope. Nope. Where are those found? Just search for it and see if we can find it. These are macros, but these are, well, there's the pause resume one, but there's a Klipper web page that, oh wait, maybe here. Here we go. All right. Well, this is the main cell one, but it's the same for Klipper also. And so these, you cut and paste into the printer config. So over here, there's the virtual SD card path G-code files. It came from a site just like this. Copy this, paste it here. Now sometimes when you paste, it will come in and there'll be a space right here. And so it looks like display status is there, but it's not orange. That's because of this little space. So it is space sensitive. So make sure that you don't paste in an extra space or something like that. And that will get you where these are set up. And then there's 3 macros that you need to put in. I don't know why they don't put these in. Maybe these change often enough that they don't put them in the configuration files, but for whatever reason, they're not set up that way. So you copy all of this guy, paste it in, all of the resume, paste it in, and the cancel print, paste it in. Oh, I actually need this one. Bed mesh calibrate, I need that in mine, which is not there. So let's put that in. Now you won't have this little block, this save config block to begin with, but if once you do save something, maybe you calibrate the PID tuning, don't paste anything in this. In fact, it says do not edit this block or below. So we're going to put our bed mesh calibrate, which is being called right here without having a reference to it. Some of these will have rename existing. Now this one's base bed mesh calibrate. So what this does is there's some old files, not files, but old macros that might be named one thing. And when they update it, how they handle that is they say, hey, this replaces, anytime you see this old keyword, we're going to use this new keyword. Let's see, this one might give me an error. Let's just see if it does. All right, so here, existing command, bed mesh calibrate not found in G code, macro name, blah, blah, blah. Usually what that means is that we need to comment out, where'd it go? Comment out this rename part. Let's see if that fixed it. So that fixed it. So sometimes you don't have the old file name and it's trying to rename something that didn't exist, and so you have to comment out that rename existing. And sometimes you do. I think I have others in here. Yeah, like here's one, rename existing pause base. And you do need that line in there, but sometimes it never had that old keyword to begin with, and so you comment out the rename existing part. Once you get your printer configured with all the stuff, so these should be pretty straightforward. You just cut and paste them from a site like this one. The web address is up there at the top. Now this is mainsail, but there's a similar one for Klipper, and it's the exact same macros. You paste those in. It doesn't matter where in the printer config you paste them, other than not below any kind of save config block. You probably don't have one to begin with, but anywhere else it's fine. Make sure that you don't have any that started out, you copied an extra space and they don't, that one is not active now, so make sure you don't have any empty spaces. Save and restart. We've already done that, so we don't need to start it again. And then when you go to your main panel here, everything will be active. So if you've set up the right microcontroller, that MCU line with the correct name of your particular microcontroller, you've gone through and put all those macros and pause resume commands into your printer config. You have printer config on the SD card in the right spot, which we did a little bit ago. Then it should be ready to run. So you have Raspberry Pi running. It will plug into your control box on your printer. It'll come on, so your printer's screen and all that will be on, but you can't do anything until you turn the main printer power on. So you turn the main printer power on, and then you can home. So home and X and Y, and it will go in and home the machine. If there is that not necessary configuration, there's the startup set of things where you do want to go in and do a PID tune. You can do all of that from right here. All of the PID tuning. You can do E-step tuning over here. And this one does have E-steps done a little bit differently. So the Ender 3 and other printers like that, when you did E-steps, you were putting in the steps per millimeter, I believe. Here, if we look at printer configuration, all of this you can edit without having to do any like special connection. You're already connected. So you can go in here, find your extruder section, rotation distance. This number right here is E-steps. It's not E-steps, but it's what relates to E-steps. It's actually the inverse of E-steps, I think. I have to think if that's, well, it's related to E-steps. And it'll be a number that is pretty generic for what your printer should ship with. But if you've changed anything, like on ours, we changed the size of the drive gear, so we have a different E-steps than what we started the Ender 3 with. So you calibrate them the similar way. So you would go over here, heat up your extruder so that you can actually feed filament. I do the one where I remove the Bowden tube, let it spit filament out of the feeder, and measure how much it spit out versus how much it asked. So I asked for 100 millimeters, hit extrude. It won't do that unless the heater is on, but it's not actually going through the heater the way I do it. I cut that little piece that's extruded out of the feeder. I cut it off and measure it, and it's 80 millimeters or whatever. And then you go to your configuration, edit, find the extruder section. You take this number that exists, 22.597, times, in our case, if it extruded 80 millimeters, times 80, divided by what you asked for. I asked for 100, so 22.597 times 80 divided by 100, and that's your new number to put in here. So the calibration part is way simpler this way. It's just a ratio. And it was a ratio before, but it was a little bit more confusing on how that ratio worked. In our particular case, we had changed out the hot end, which we also changed out the thermistor. So we put in the E3D cartridge thermistor versus the original glass thermistor. These values that you copy off of that configuration are assuming everything is stock. Everything's the extruder stock, the thermistor stock, the heater stock, everything's stock. And so if you've changed anything, then you do have to change that in your configuration. So I no longer had the thermistor that came with the Ender 3. I had that cartridge thermistor, and so I had to tell it I'm using the ATC Simatech 104 GT2 thermistor. You probably shouldn't have to change any of the pin locations though. It doesn't know if you have a BO Touch, so you got to add a BO Touch. Now do not copy this. I think this might be what hurt my board over here, this guy. Different boards use different pins for the steppers and the BO Touch and the fans and the end stops and everything. This pin 4 is the pin on the 1.1.4 board. On this board, this is pin 4, or well, no, the BO Touch is pin 14. So make sure you're using the correct pin location, because you are going to set this pin up as a drain basically, and you don't want that to be connected to like a stepper motor driver and not the BO Touch. So there is some setup, and this is the more difficult part, where you can find where a person, you search on Google, you find a person who has set up their printer to do the BO Touch, and you say, oh great, I'll copy that. But you have to be very careful if they're doing the same setup that you have. Do they have the same board? Have they changed anything from what you have changed? Their offsets are probably different from your offsets, and so you do have to go in and make things like this offset here. When you copy this from the sample, is not what I have on mine, because I have a different mount for my BO Touch. And so you have to make sure if you've changed anything hardware wise, then some of these numbers, these pins might be different, and so you do have to be very careful on that part. Let's see. At that point, it's tuning, and there's several, you want to check to make sure all your end stops work, and so it's not going to crash into something. Those first few rounds, you want to be right there beside it, ready to shut it down. There's an emergency stop up here too, but shut it down manually in case it's not recognizing something. If you have a stock printer, no BO Touch, pretty much stock, then it's really straightforward, and you can get to printing right away once you get that stock printer configuration loaded. But if you've changed things, it does take you some more effort to try and get it all tweaked, and it's going to be tougher to find that on already done somewhere. The more things that you have done to your printer that make it unique from all the other printers are going to make it more and more difficult to find a pre-built thing. But once you get this running, it's super easy. You want to change your E-steps, you can do that just by editing this line. You want to change your maximum accelerations or whatever, you can, right here they are right in here, max velocity, max acceleration, you can change it right here. You want to change something during the print, it's right here, probably somewhere on here is probably what you want to change. Maybe you want to print faster or slow it down. You want to increase the flow. All of these things or many of these things you could do through the LCD screen before, but right now my printer is in an enclosure and the LCD screen's in that enclosure, so I have to open up the enclosure to change anything using the LCD screen. Now I guess I could relocate it outside and still do that. There's no cost to this other than you do have to buy a Raspberry Pi, but if you're not going to do Octoprint and you're going to use this instead, then you can get one of the cheap Pi Zeros and do this. So it's a pretty nice setup, and it does the remote thing. You don't have to be connected to your printer other than wirelessly connected through your Wi-Fi, and so it does give you some new features, and it opens up the this board now. I'm not limited by the board having to do the processing of the G code. Raspberry Pi is doing the processing. The board can run at full blast, just controlling steppers and measuring thermistors and stuff like that, which it's very good at doing that. And the next thing I want to do, I don't think we'll do this on Wednesday. Maybe we can do part of it on Wednesday. The next thing I want to do though is use Klipper to instigate, or is that the right kind of word? I don't know if that's the right word for what I want to say here, but implement. That's what I want to think of. Implement input shaping, which is where we can go in and predict vibrations that are going to happen. And I mentioned before that we can use accelerometer to do that. So we can physically mount the accelerometer onto the printer and measure the vibrations that way. It's not real time. You measure them ahead of time and then predict them when you're doing printing. So the accelerometer only is on the printer when you're calibrating it, and then once you get it all calibrated, get your input shaper calibrated, you take all of the accelerometer off of there, and it's just predicting the vibrations. That would be really cool if it was measuring them real time and accounting for them, but that's not the way it works. It's a prediction. So we can do that. You don't have to use the accelerometer though. You can use some test prints that are designed specifically to measure the shape that you would want for the input shaping. I think that might be what we do first, but I won't have time during a stream to print the prints. You know, it's gonna they're lengthy prints, so I'll print them ahead of time and measure them. And so that's one thing I want to do. We're getting really close to the end of the quarter. So we've just got a few things left. I don't know that if these are the things that we'll do, but like I do want to put input shaping in, and maybe we can get the non-accelerometer version up and running for Wednesday. Other thing, I did start using a new slicer with Klipper because it is specific. It has some profiles specific to Klipper, and it is this one, yeah. Super Slicer. So it's built on Slicer, but it's built on Prusa Slicer's implementation of Slicer. So Slicer is a older open source slicer, and Super Slicer is built on top of Prusa Slicer, which is built on top of Slicer. So it looks a whole lot like Prusa's Slicer. In fact, I have it open somewhere here. Here it is. So it looks a whole lot like Prusa. But it does have some additional features, and it has some profiles specific to running Klipper. So I've been using it. So far it's okay. I haven't seen any real problems with it, but it will. Let's see, is that off? Yeah, there we go. I can set it up where it will send directly to the printer. So I can slice something and just send it straight to the printer. I don't have to go through Fluid at all. Fluid, I can, remember it does have that jobs list where I can upload files and do that here. But this Super Slicer, I can just send it straight to the printer from here, assuming I've set the printer up to do that, which is in the printer settings, I believe it is. You set in its IP address. I don't remember which one that's in. It's in one of these settings somewhere. Oh, this is a replacement cover for the control box. when I went back to the 1.1.4 board with the BL Touch, I have to use an adapter, and that adapter makes it where the fan hits the adapter, and the lid here won't close right. So I had to print a different lid to mitigate that problem. Okay, so I think that is all of the steps that you would have to follow, and all the little things you might fall into where it's not clear, that you should be able to, if you wanted to, get Klipper up and running. I can't go through every possible iteration of your combination of BL Touch or not BL Touch and your motherboard on your printer and every combination possible, but I think that gives you a good enough idea that with a reasonable amount of effort you could probably find the right set of configurations. I know the first time I did this a year ago, it took a long time to figure out what they were saying about certain different things, and that configuration file in particular. So hopefully this walkthrough will get you up and running without having to try to search all over the internet. And it's confusing because everybody's talking about their printer, and that's not the same as your printer in many cases, particularly if you've changed something hardware wise. All right, we'll be back Wednesday. I think we'll do some of the input shaping using Klipper, and maybe throw some other things in there as well if I think of something, maybe that nozzle X, see how well it's working or not. And we'll be back on Wednesday. And if you have any particular topics you want me to cover, we only have a few lectures left, so let me know. And if they're not already on the list. I'll see y'all Wednesday.